Welcome. Today we are going to learn how to use our trig functions to find missing side lengths of right triangles and missing angle measures. Before we start that though, I want to let you know that I have attached this trig formula sheet to your assignment that you can download and print off. Basically, it's just a reference sheet for you to use so you can remember the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. It also gives you the cosecant, the secant, and the cotangent. You won't use those nearly as much. These first three are the most important ones. It also references these three special angles or two special right triangles, the 45-45 right triangle and the 30-60 right triangle. By the way, these two are really the same, these two triangles. This is a 30-60 right triangle. This is a 30-60 right triangle. What I've done, though, is I've referenced the 30-degree angle here. I've referenced the 60-degree angle here, and this is the 45. And it's all 6 trig functions. So it tells you the sine of 45 is the square root of 2 over 2. Now, I do want to emphasize that I've rationalized the denominator on a bunch of these. For instance, the sine, which is opposite over hypotenuse, sine opposite over hypotenuse, is 1 over the square root of 2. But when you rationalize the denominator, it gives you the square root of 2 over 2. So you have all the 6 trig functions for a 45-degree angle, you have the 6 trig functions for a 30-degree angle, and you have the 6 trig functions for a 60-degree angle. We're going to reference those in order to do some of today's homework. A lot of the homework today, though, will be able to be done on just using a calculator. So if you have your calculator and you can do your sine and inverse sine, remember you got your sine, cosine, and tangent buttons, and then the inverse sines, those ones with the little -1 above them, you hit the second key. Make sure your calculator is in degree mode. But let's do an example of one where you do it without a calculator. So we're going to be doing lessons 8 and 9 today, finding a side length and finding an angle measure. The side length is the one that some you'll have to do without a calculator. The angle measure, you could do all those with the calculator if you wanted to. But let's look at one of these side length ones. The most important thing is looking to see what your angle measure is. If your angle measure is a 30, 60, or 45, you're going to use one of these reference triangles. And these first few are, this one's a 30-degree angle. So we're going to be using one of these 6 ratios here, or 6 trig functions, because I'm using the 30-degree angle. The next thing that you need to make sure you do that's most important is make sure you know what side you're looking for and what side you have information on. So for instance, I'm looking for UV. UV is this side with respect to the 30-degree angle. Well, that side is the adjacent. So I'm looking for the adjacent side, and I know the hypotenuse. So I look up here and I try to find a trig function that uses the adjacent and the hypotenuse. Oh, that's the cosine. So what I'll do is I'll take a piece of scratch paper and I'll say the cosine of that 30-degree angle, this cosine of 30 is this unknown side x, divided by the hypotenuse, which is 10. Now that fraction should equal the cosine of any 30-degree angle. So I can come up here and I use my reference angle, cosine of 30, my reference triangle that's referencing the 30-degree angle. The cosine of 30 should be the square root of 3 over 2. That's a square root of 3. It's kind of hard to see, but it's a square root of 3 over 2. So I say this is equal to the square root of 3 over 2. Now what I do is I ignore this cosine of 30 part, and I just take this expression and I solve for x, because this fraction must equal that fraction. So I multiply both sides by 10, and the 10s cancel on the left. 2 goes into 10 5 times, and I get 5 square roots of 3 as an answer, because it asks you for an exact answer in rationalized form. So I type in 5 square roots of 3, and I hit submit. Right? Now here's a 45-degree angle. And so we'll end up be referencing the 45-degree angle. But let's first see what it's asking for. It's asking for RT. RT happens to be the adjacent side with respect to 45. We also know the hypotenuse. So again, the adjacent hypotenuse is the cosine. I want to emphasize it's not always going to be the cosine. Sometimes it'll be the opposite we're looking for. Sometimes it will be the opposite and we'll know the adjacent. So you will use tangent and sine as well. This one happens to be the cosine again, but we do the same process. I take the cosine of my 45-degree angle. That equals, now look back over on the triangle you're given, the unknown adjacent side. So I'm going to do x over the hypotenuse, which is 16 square roots of 7. And that equals, so now I come back up here and I look at my cosine angles, or cosine of 45. Cosine of 45 is the square root of 2 over 2. So that equals the square root of 2 over 2. Now I ignore the cosine part because these two fractions must be equal. I times both sides by 16 square roots of 7. 16 square roots of 7. That cancels on the left, leaving just x. On the right, 2 goes into 16 8 times, and 2 and 7 combine to give me 14, so I get 8 square roots of 14. Come over here, type in 8 square roots of 14. Now, those ones came out to be exact answers, and anyone that has this nice 60-degree angle or a 45 or a 30 will. You will get to some that are not those nice angles, and those are the ones you'll do with the calculator, like this one. So from this point forward, I'm not going to reference these special right triangles, but I am going to still have to use these ones to figure out what I'm going to do, which trig function I'm going to use, and then I'm going to use my calculator. So let's look at our triangle so you can get an example of this. First of all, I'm given this angle. I know the hypotenuse, and what side am I looking for? I'm looking for HJ. HJ. Again, that's the adjacent. They're using the cosine. And I want to emphasize that you will get some that are sine and tangent. But this one happens to be the cosine of 42 degrees is equal to, cosine again is this unknown adjacent side, x over the hypotenuse, 6. Now, I don't have a special right triangle, so what I'm going to actually do is I'm going to use my calculator to find the cosine of 42. So again, make sure your calculator's in degree mode, which I always hit mode, and I look, okay, yeah, my calculator is in degree mode. It's always the first thing I do. And now I'm going to take the cosine of 42 degrees. That gives me 0.743. So I know that 0.743 equals x over 6. Now all I got to do is solve for x, multiply both sides by 6. It's almost simpler than the reference triangles. So I times by 6. So all I'm doing is I'm timesing my previous answer by 6, and I get 4.45. It says to round to the nearest tenth. So if I round that, x being 4.45 to the nearest tenth, that's going to go up and it'll be 4.5. So I type in 4.5 and I hit submit. Just like that. All of these will be very, very, very similar. I'm going to do one more of these and then we're going to talk about missing angle measures. The reason I'm going to do one more, this one I believe is going to be using the tangent. So I'm going to be doing something other than cosine. I have a 32-degree angle. I know the opposite side, and I want to know HI. That's the tangent. That's the adjacent. Opposite over adjacent. So again, opposite over adjacent. That's why I said it's the tangent. So I'm going to do the tangent of 32 degrees is equal to my opposite side, which is 5, over my adjacent side, which is x. Now, another reason I wanted to do this one is because I have my variable on the denominator. I'm still going to find the tangent of 32 first, though. Clear. Tangent of 32 gives me 0.625. So I'm going to go 0.625 equals 5 over x. I need this x out of the denominator, so I'm going to multiply both sides by x to get the x out of the denominator, and then I'm going to divide by 0.625. So I'm going to divide that 5 by 0.625. So on my calculator, I'm going to just go 5 divided by that previous answer, that 0.625. That's what I'm doing, 5 divided by the previous answer. And I hit enter, and I get x is 8.00. But it says to round to the nearest tenth, so it's just 8. And I hit submit. So those are the missing side lengths. The other lesson that you're going to be doing is finding the missing angle measure. Now, the first few you could do using your special right triangles like we did the first few on the other ones. You could use these, but you can also just use your calculator. The warning I give you, though, is with calculators, you got to be very, very careful. Your calculators will follow order of operations, and you will get an incorrect answer if you don't realize how you're typing in your problem into your calculator. And I'm going to explain that. Here we have this triangle here, and we're looking for the measure of angle R. That's this angle. So again, we got to make sure we know what angle we're looking for. I almost went to S, but we want R. Okay, what two sides do we know with respect to R? Well, I know the opposite side, and I know the hypotenuse. That's the sine function, opposite and hypotenuse. Again, we look back here for our trig function that has the opposite and the hypotenuse. That's the sine. So I'm going to do the sine of some unknown angle R is equal to 10 square roots of 2 over 20, because it's the opposite over the hypotenuse. Now I can reduce that, by the way. 10 goes into 20, so it's just the square root of 2 over 2. This is when I said that you could use your reference triangles. I'm looking for a sine function whose ratio is the square root of 2 over 2. So I come over here and I look for the sine function of, oh, right there, it's that first one. This is 1/2, sine of 30 is 1/2, sine of 60 is square root of 3 over 2, but the sine of 45 is the square root of 2 over 2. So I just come over here and I say, oh, that's a 45-degree angle. Now, I'm going to emphasize something. I could have used my calculator if you wanted to. I could do the inverse sine, and then I can do the square root of 2, and then make sure you tab over to get out from underneath the square root, divided by 2, close parentheses. So now I'm looking very closely at this to make sure this is doing my math right. I'm going to take the square root of 2, then I'm going to divide that by 2, and then that's all in parentheses, so I'm taking the inverse sine. And I hit enter, and guess what I get? 45 degrees, just like I got with my reference triangle. And I hit submit. Right? So there's no reason you can't do all of these with the calculator, but some can be done without a calculator. Okay? So let's look at one more. I want to do one that isn't a special one, that won't give us a special angle measure, like this one here. Okay? We are first given this triangle here, and we're asked to find the measure of angle J. J is down here. J, the two sides we know, is the opposite and the hypotenuse. So again, I look at my reference sheet, opposite and hypotenuse is sine. So I'm going to do the sine of J, because that's the angle I'm looking for, is equal to the opposite side, which is 8, over the hypotenuse, which is 9. It's 8 over 9. Now again, you're not going to find this ratio in our special right triangles. So what you'll do is you'll use your calculator. Okay? I'm going to find out that J equals the inverse sine of 8 over 9, because I'm undoing that. So I take my calculator and I do the inverse sine of 8 divided by 9. And I hit enter, and I get 62.733955 degrees. If you'll notice, it says round your answer to the nearest tenth. So the nearest tenth on this problem here is going to be 0.7. So I'm going to type in 62.7. So just be very, very careful when you're using your calculators that you make sure you're following order of operations on your calculator. These assignments should hopefully not be too long. If you do have questions, please do contact me through email or log on at 1 o'clock during my online office hours, and I will help you.